simplify the expression. We've got the integral here of x cubed minus x squared minus 19x plus 38 all over x squared minus 6x plus 9. So we're integrating that sort of expression. So immediately we can see, hey, this is a rational expression. Okay, rational being polynomial. There's one polynomial over another polynomial. So when it comes to integrating rational expressions, there's two thoughts that you should have right away. Okay? The first thought, and this is a small one, it's probably you're going to be your first thought in some cases. In some cases, you're not even going to think this thought because it's so fast, but it's to check the degrees. Okay? If the degree on top is bigger than or equal to the degree on bottom, what you have is an improper rational, and we'll have to take care of that. The second, and this is the thought you're always going to have, is what are the factors of the denominator? Right? Now, sometimes you get lucky and somebody's already factored it for you, but what are the factors of the denominator? So we already recognize that's almost immediate that this is an improper rational, which means we are going to have to rewrite it. We're going to have to do a polynomial long division. But while we're here and talking about it, okay, let's factor this. Now it's a quadratic. Let's see. Two numbers that multiply to 9, so 1s, 3s, 9s if we get nice integers. -3 and -3, because they'll two negative 3s will add up to 6. So this is x minus 3 squared. So we have a repeated linear factor, and that's it for the denominator. So we'll put a pin in that. We'll come back to that later, but right now we need to deal with the fact that it's an improper rational. So the way we do that is by rewriting so that it becomes a polynomial plus a proper rational, and then we'll just integrate the polynomial by itself and the proper rational with our partial fractions technique. So, right, we're doing a long division, so let's set up our long division. So it's x cubed minus x squared minus 19x plus 38. I'll go back and check that. And if they had given us the denominator factored, which can be nice for the partial fraction decomposition, we would have to expand it because to do the long division, to get the proper rational, we do need the actual polynomial written out. So we put everything in decreasing decreasing order, left to right, for our powers of x. Minus 19x plus 38. Okay, we're good to go. So now we just start doing our long division. So we'll take a look at the leading term left over here in the dividend. Okay, how many x squareds are in x cubed? That's pretty simple, just x. When you're doing a polynomial long division, it's very important that you stay organized, keep sort of all the degrees aligned properly, because if you're doing a long one and it gets messy and you're sort of squishing yourself over and over into the page, you can have things misaligned. You might subtract this or that wrong. I've seen it happen more times than it should, really, from some people. But, you sort of have two options. I like putting my x above where I just was. Helps me keep place of where I am in the division. But you might say, well, no, this is the x cubed column because I'm trying to stay organized. Well, okay, put your x over here. That's fine. But now that we have this new term, the first term of our quotient, we go ahead and multiply it over here. X cubed minus 6x times x, that's 6x squared, plus 9x, and then we will subtract. There we go. X cubed minus x cubed, yep, they should cancel out. If they don't cancel, if those first two don't cancel out, you have done something wrong. Negative x squared minus 6, that's negative 1 plus 6, that's 5x squareds. And then minus 19, subtract another 9, that should be minus 28x. We'll pull down the plus 38. Now we ask ourselves, let's use orange. Okay, how many times does x squared, just the leading term here, go into 5x squared? And we can do a quick calculation, and oh, look at that, it's 5. So we'll put the 5 over here, continuing with that trend. And then we multiply through. So 5 times negative 6 is negative 30. 5 times 9 here gives us a constant of 45. And we will subtract. Those ones cancel out. Good. Negative 28 minus, so negative 28 plus 30, that's going to be 2x. And then 38, so negative 28 plus 30 is going to give us the 2. And then 38 minus the 45 should give us a minus 7. The degree here is less than the degree of our divisor, or the denominator of the fraction, so we know to stop. This is the remainder polynomial. This is the quotient polynomial. And so when it comes to doing the integration, I'm going to write it now as x minus 3 squared because we're starting to move into the integration, so we'll need the partial fractions. What we have here is this whole expression is the same as x plus 5 plus, and then we put the remainder up on top. It was 2x minus 7, right? Yeah. And we can split this up. We can say, well, I know how to integrate x plus 5. Right? It's a polynomial. In fact, that's really quick. X squared over 2 plus 5x. And then we're going to have to deal with integrating this proper rational, because the degree on top is 1, whereas the degree on bottom is 2. So how do we do that? Well, that's where the partial fractions decomposition comes into play. Okay, so let's focus on that. So how does it work? Well, when we've got a repeated linear factor, like x minus 3 squared, the setup we do, each linear factor gets a constant, and you're going to have a linear factor for just x minus 3, and then another for x minus 3 squared. So our theory of partial fractions, of polynomials, and rational functions says there is a unique constant a and a unique constant b that makes left-hand side equal right-hand side. So let's figure out what those are. Okay, so multiply everything by x minus 3 squared. You'll be left with 2x minus 7 here. One factor of x minus 3 squared will cancel out with what we've got down here. So you'll have a times x minus 3. But they'll both cancel over here, so we'll have plus b. Now, there's lots of ways we could do this. We could expand the polynomial on the right and equate coefficients. That certainly works just fine. But what I'm going to do, I'm going to do a little trick. I'm just going to plug in x equals 3. Because if these polynomials, even though I don't know what a and b are, if these polynomials are equal, then when you plug in numbers, you should get the same number on each side. So 2 times 3 minus 7 is negative 1. But why did I choose 3? Because of plugging in 3 here, 3 minus 3 is 0. 0 times a, we can ignore it. And you've got b just on the right. So b is negative 1. Now that I know b is negative 1, if we go back here, we got this minus 1. We can add 1 to both sides. And you'll get 2x minus 6 is a times x minus 3. And then you could factor 2 out here. 2 times x minus 3 is a times x minus 3. So we sort of just see, oh, well, a's got to be 2. So a is 2, b is minus 1, and we are ready now to integrate this. So this integral turns into, so you do a was 2 over x minus 3, right? It was 2. And then we could say minus 1 for the b. I'm just going to say minus and put a 1 on top of x minus 3 squared. And now we integrate these. So this is the first one, 2 ln absolute value of x minus 3. I mean, you might have done enough of these that you can sort of do it by inspection. If not, do a substitution. Same thing over for this one. Substitutions would work, or you can, this is a pretty common thing, so you can memorize a formula. So minus 1 over a, which in this case is 1, times n minus 1, that's my n, so times another 1, times x minus 3 to the n minus 1. So the minuses cancel out. No one writes times 1 on the bottom, and no one writes to the power of 1. So this, oh, and let's not forget our plus c, because we're done doing an indefinite integral. We'll have 1 over x minus 3 plus c. So this piece combines with the polynomial integral that we already did, and then we will have the integral for the whole thing. So x squared over 2 plus 5x. So this is our full final answer, x squared over 2 plus 5x plus the 2 ln absolute value x minus 3 plus 1 over x minus 3 plus c. Let's just make sure we got each part correct. Yeah, that works good, and yeah, that looks fine as well. So this is our final answer. We have simplified the indefinite integral.